This is video help on homework number 11. I'm going to go through this kind of rapidly, so if I'm moving too fast, you might want to pause the video to write a few things down. The first question here we did not cover in class yet. That deals with finding the magnitude of a vector. If you have a two-dimensional vector, you write it like this. F equals some x component in the I hat direction plus the y component in the j hat direction. So the I hat means along this way, the j hat means along that direction right there. So the resultant vector, if this is the x component and this is the y component, the resultant is over like that. And we're trying to find the magnitude of that. We'll call it f. Another way to write it is magnitude. And it's equal to the square root of f of x squared plus f of y squared. That's for a two-dimensional vector. So if you have, let's say, 3 in I hat plus 4 in j hat, the magnitude of that vector is equal to the square root of 3n squared. Notice the I hat doesn't appear down here. Plus 4 newtons squared. The j hat doesn't appear down here. And the answer for this one just happens to be 5 newtons. So the units work out, and the number happens to be that. This is not the problem we have on the homework, but it's a similar one. The one you have on the homework, excuse me, is a three-dimensional vector. So to find the magnitude of it, you just take that Pythagorean theorem looking approach, and you say f of x squared plus f of y squared plus f of z squared to find the answer for the magnitude of this three-dimensional vector right there. So the answer is not 10 minus 10 plus 5. It's going to be found using this equation right here. For problem number 2, these were discussed in class, and they're also in the very beginning of chapter 10 as well. You might notice that in the textbook on Newton's laws here, make sure it says a square right there. I think there is a type in an error in the textbook.